Hi again, everyone. In the past videos, I showed you how to create technology-based activities. And sometimes when I tell people that I develop educational technologies, they say, oh no, you want to replace teachers, including my own grandmother, actually. But really, that's not at all what I'm trying to do. So I want to tell you about one of my studies that looked at the role of instructors while students work with technology-based activities like the ones that I showed you in the past videos. This is a study that I did with the help of some of my undergraduate research assistants, and we all took several road trips to a high school here in Wisconsin. At the high school, we then organized a chemistry workshop for the students there. And as part of the workshop, the high school students worked in pairs with our ChemTutor system and also with physical manipulatives without any technology help. When we started the study, we were mostly interested in how the students, when they work in pairs, help each other understand how visuals like ball and stick models and Lewis structures show chemical bonding. So we videotaped the interactions among the students. But when we saw that the students often asked for help from the instructors, who were actually my research assistants, and they had all received training on how to explain the chemistry content to students. So we saw that students often asked for their help, so we ended up including the interactions between the students and the instructors in the analysis. It's actually not straightforward to analyze videotaped interactions, so if you're curious about some of the details of the analysis, you'll find a link to the research paper about this study below. But in essence, what we did is to tag the conversations with codes. For example, a student in the study pointed at the dots in a Lewis structure and said they want to be able to make a complete number of 8 on the outside. So this student is actually talking about the octet rule, which is an important concept in chemistry. So then I would add a tag to the statement that the student mentioned a concept. And also, because the student pointed at the Lewis structure, the student was also talking about the visual. So I would also tag the statement about talking about a visual. And I would also add tags that tell me whether the student was talking to another student or to an instructor. Now, what I was most interested in actually was when students connect the visual to a concept. Like in the example, the student was talking about the visual, the Lewis structure, showing a concept, the octet rule. And this is not straightforward, so I find that a pretty nice achievement on the part of the student. So what I wanted to know is what happens leading up to these concept-visual connections. To find that out, I used a data mining algorithm, and without going into too much detail, you can imagine an algorithm as a small computer program that tries to find a rule that predicts whether something happens. As an analogy, imagine Netflix wants to know what predicts whether somebody likes the Frozen movie, and then Netflix would use an algorithm to predict if a user would like that movie. So presumably you'd be more likely to like Frozen if you often watch children's movies or if you like other Disney movies. So analogous to that, my algorithm tried to predict if students would make a concept-visual connection based on what they said before and based on who they talked to. Now, if students worked with the physical models and did not have the help from the ChemTutor system, I entirely expected that having talked to an instructor would be predictive of making a concept-visual connection. And the data was in line with that. So usually right before students made a concept-visual connection, students had talked to the instructor about the concept or about the visual. Now, when they worked with the ChemTutor system, the results were actually very similar. So right before students made a concept-visual connection, they had often talked to the instructor. But if an instructor was not present, concept-visual connections were often preceded by one of the students voicing confusion and their partner trying to help them. So what stood out to me from this study was that instructors played a very large role in students understanding visuals, and that was the case even when students had a lot of help from the educational technology. But also, this study sparked my interest in how educational technologies can help students help each other. And I'll tell you more about that next week. I hope you'll join me then.